So we're on page 19, and we didn't use this on Friday. We did cosine and tangent. Notice, do we have a little top shelf, bottom shelf thing, plus, minus, plinus? Does the thing carry over? Does it, on Friday they changed. On this one, it stays the same. So that's kind of nice. If you start out with an alpha plus beta, we're going to stay with a plus over here. If we start with an alpha minus beta, we'll go with a minus over there because the bottom shelf stays the same. Coo. So you guys, look at what they asked for. Find the value of this. This is just kind of some extra info. This is just kind of their formality. Don't worry about it. This is really what we're gonna use. But they want the sign of x minus y. How I want you guys to label that is alpha minus beta, right underneath that. So we've got alpha minus beta, and I want us to go apply this formula here. So I'm going to say, all right, the sine of x minus y equals, let's go apply this formula. What do we say first? Sine of x, cosine of y, thank you. And then if we started with a minus, I'm going to stay on the bottom, which would still be a minus. And then we'd have cosine of x, sine of y. So now, this is a little different than what we did Friday. Same equation, but I'm giving you some different info. Do you agree I can replace this sine of x with 9 over 41? I'm going to just do a simple substitution and say, well, this sine over x is 9 over 41. Do we know what the cosine of y is? We don't know yet, so I'm going to just kind of leave that blank. We're going to multiply that by something. Minus, do we know what the cosine of x is? I don't think so. Do we know what the sine of y is? Yes. Yeah, thanks. That one is 7/25. So now it's like, okay, how the heck do I go find this stuff? You guys, we've got to go use this information in a triangle. So let's picture just this sine of x1. If I were you off to the side, let's go make a right triangle. And let's go put that angle x right here. Boop. Okay, if we know the sine of this angle x is 9 over 41, so katoa, sine is always what over what? Opposite over hypotenuse. So the opposite in this one would be a 9. The hypotenuse on that triangle would be a 41. So if I'm trying to use that for some info, let's go find, because look what I need. I need the cosine of angle x. This one's the cosine of angle y, and this angle is just x. So I'm going to use this triangle to help me find the cosine of x. So katoa, what's cosine? What over what? Ooh, so ka, adjacent over hypotenuse. Do I have the adjacent? I don't, but could I go get it? Yeah, what squared plus what squared equals what squared? Oh, Beck, I give you a lot of credit because you know I know what I do to that. Tune it out. I just turned my brain off because I agree. Don't want to listen to it. Do you agree we do 41 squared minus 9 squared? And then we got a square rooted? Look at that. Guys, that's a Pythagorean triple. This side is 40. Boop, boop. So what is the cosine of the angle x? So ka. Nice. Adjacent over hypotenuse is 40 over 41. Boom. That's going to go here because this cosine of x was referring to the x angle. Can we go use that information here to set up another triangle with an angle y with that info? Yeah. Oh, thanks, Graham. Here we go. My next triangle is going to be angle y. And they said the sine of y is 7 over 25. The sine, so, S-O-H, 7/25. Opposite over hypotenuse, yeah? Can anyone remember what that triple is? This one's way more common. 7/25? Oh, that's a 5, 12, 13 triangle. Good call, but nope. Correct me if I'm wrong. How would I find it? Just in 2 steps on my calculator. What squared? 25 squared minus 7 squared. Square rooted. Any ideas? 7, 24, 25 is another triple. So 24 is this adjacent side. Come on, little buddy. Okay, so then right here, we need the cosine of y. That goes right here. This is my angle y, so the cosine, so ka. Say that again. 24 over 25, adjacent over hypotenuse. You will 100% have a calculator for this stuff because look at this answer, gross. Let's go type this into my calculator and we would just be multiplying straight across. And let's see what we get. 9/41 times 24 25ths minus 40/41 times 7/25. Math, enter, enter. Uh-oh. I did get a negative. See if you guys get what I got. Negative 64 10/25, which is about negative 0.0624. Okay, you guys, let's try this bottom one here. Whoo! Verify. Gross. Verify that this angle plus this angle equals negative secant. Which side do you think that we should work on? Left side. Agreed. Cosecant is the reciprocal of which function? 1 over sine, right? So the cosecant of this is going to be the same as 1 over the sine of 3 pi over 2 plus a. That's the exact same thing that I started with. Now, can I break this apart using that exact formula that we just used up here? I'm actually going to take a little picture of it, bring it on down. Boop. Okay, so can we use this? Oh, this is going to be a problem. This is going to be a problem. Can I just get this? Yes. No. Yes. Okay. Can we use this for the bottom? Because we have some angle plus some angle. That's an alpha plus a beta. We can do that. So people, let's go ahead and label. I'm going to put this as an alpha plus a beta, which might throw you off because I'm changing an A to a B. But I just want to help myself use this formula. So I'm going to keep that 1 over. We got 1 over, a lot coming. Instead of sine of 3 pi over 2 plus a, Evan, that's what a pi looks like. Let's go plug this in. Alpha plus beta. Here we go. Sine of, what would we say first? Times the cosine of, good. Sine of 3 pi over 2 times.
What happens to the sign that's outside of parentheses?
Good call. So let me rewrite this actually. Because to your point, I'm going to just take what I had, 1 over the sine of 3 pi over 2 plus a. This is equivalent to 1 over, and we're just breaking this thing apart. Because look what they're saying. When you're given the sine of two angles being added or subtracted, that is the same as breaking it apart this way. Okay, so instead of writing this here, I'm going to go ahead and say, all right, I would have the sine of 3 pi over 2 times the cosine of a in this case. Is that right? Because I did sine of alpha times cosine of beta. Sine of alpha times the cosine of beta. Plus or minus if I started with a plus on the top. Plus, I'm going to keep that. Plus the cosine of, you know it, sine of, beautiful. You guys, we need all of this to equal negative secant of a. Weird. Let's try something. The sine at 3 pi over 2. The sine at 3 pi over 2. Sine, what is the sine at 3 pi over 2?
-1.
Very good. The sine, the y coordinate at 3 pi over 2 is -1. So I'm going to replace this guy with a -1. This guy just became a -1. I can highlight it instead. That guy replaced. Cosine of a. I can't break cosine of a down, so I'm just going to write cosine of a. What about the cosine at 3 pi over 2? Yeah, the x value at that same coordinate is 0. So if the x value is 0, I've got plus 0 times sine of a. What's 0 times anything going to do? Nothing. So I'm left with 1 over negative cosine of a. Look what we want, you guys. Negative secant. 1 over cosine is secant, and we had a negative, so this is negative secant. We did it. Now, this is saying, hey, what's the tangent of pi over 12? You agree, Mr. Greer? That we don't have any pi over 12s on my unit circle. We don't have any 12 pi's. What I would do if I were you is let's go write all of our pi's in terms of twelfths? Whoa. What would pi over 6 be in terms of twelfths? 2 pi over 12. Is that still 1 pi over 6?
Yeah.
Okay. Pi over 4.
3 pi over 12.
Yeah. Uh-huh. So I would definitely write these down because I'll show you why we need this. Pi over 3?
4 pi.
He says 4. 4 pi over 12? Pi over 2?
6.
6 pi over 12. Let's go one more. 2 pi over 3.
8.
The enthusiasm is really infectious, Evan. Okay, I feel like that's good enough. Look what they want on this problem, you guys. They want to know what the tangent at 1 pi over 12 is. What could I add or subtract in order to get 1/12 of a pi?
3 pi over 12 minus 2 pi.
Is 3/12 minus 2/12 1/12?
Yeah.
What about 4/12 minus 3/12? Is that 1/12? Yes. Which one do we want to go with? I vote what Beck came up with. Beck, you're saying 3/12 minus 2/12 is 1/12. Could we rewrite that instead of using the big ones? Could we just say 1/4 minus 1/6? Like its equivalent broken down ones. Okay, you guys. So what we're going to do right next to this, we're going to say the tangent of pi over 12 is the same as pi over 4 minus pi over 6. And one more time, Beck said that because 3/12 minus 2/12 is 1/12. And so this is exactly the same as that. So there's that tangent formula. Do you agree that we used minus to start? So I'm going to highlight. We used bottom shelf, so I'm going to stay bottom shelf. Here we go. We have an alpha minus a beta. You can just write an A and a B. I don't care. So you agree. And this left side is right here. It's going to equal tangent of what should we start with?
Pi 4.
Yeah, tangent of pi over 4. Plus or minus? Minus tangent of, beautiful, over 1 plus tangent of times pi over 6. Oops, tangent of pi over 6, my bad. Okay, people. Friday, this was brutal because there was just a lot of simplifying. Here we are. We got to think, what is the tangent of pi over 4? It's my favorite one, honestly. Yeah, tangent of pi over 4, any fourth, it's always just the same thing over itself. So we just have 1. So the tangent of pi over 4 is just 1. So on top, we've got 1 minus. Tangent of pi over 6 is actually my least favorite one. Oh, look at that. Tangent of pi over 6 is 1 over root 3, which is root 3 over 3. Gross. Okay, so we got root 3 over 3. Over 1 plus. That tangent of pi over 4, we found it right above. What do we use for that? 1 times root 3 over 3. Because we get to use those same values. We just multiply them down here instead of add them. Perfect. You guys. What's the matter? We got to use the conjugate. Before we do that, let's get condoms. Let's get condoms. On top, what would this turn into? Wouldn't this really be 3 over 3 is the same as 1?
Yeah.
So we really have on top 3 minus root 3 over 3? FJ, you down with that? Okay. Tune in. What about on the bottom? Yeah, you're saying, hey, we got a 3 over 3 right there. My 1 times root 3 over 3 really isn't going to affect anything. So it's really just a root 3 over 3 again. So on top, we'd have 3 plus root 3 over 3. Awesome. Can anything cancel? Bye. Yeah, thank you for clarifying. There's 53 staring me in the face. Very good, you guys. Okay, we're so there. And then, so if you are right, we're at 3 minus root 3 over 3 plus root 3. And you guys, the reason we want to use the conjugate is we cannot have this square root. We cannot have a square root in the denominator. The conjugate will say bye. The conjugate will get rid of it. Here we go. What is the conjugate? 3 minus root 3. People, all right, here we go. Top shelf, we ready? What are we going to get first? 9 minus 3 root 3 minus 3 root 3 again plus, root 9 times, root 3 times root 3 is root 9, which is just 3. Negative times negative is positive. Bless. On the bottom, we got a 9 again. Then do I get to cancel out negative 3 root 3 and a positive 3 root 3? And then minus 3. So what's going to simplify up here? Nice. He says 9 plus 3 gets me 12. Negative root 3 minus 3 root 3, my bad. Negative 3 root 3 minus 3 root 3 is negative 6 root 3. All over? 6. Final answer.
2 minus 6 root.
Yeah, girl. Wait, 2 minus.
Oh, yeah.
Root 3.
Yep, nope, you got it. Now, because you will 100% have your calculators on the quiz, do you think it's worth just typing in this and seeing if it's the same as that? Yeah, what mode does my calculator need to be in if this has pi over 12 radians? So because look at the next question. The next one's degrees. So you would want to, you got to just make sure I would have to be in radians. And then I could say, hey, what's the tan at pi over 12? Oops, pi over 12. And then our answer was 2 minus root 3. And we got the same thing. So you could be like, Now, things that you can't do, give me that decimal answer as your answer. Got it? No decimals. Let's actually just set it up. I don't even need to finish it. Secant at 795. What the heck? I completely agree. 1 over cosine of. And I'm not even going to write 795. What do we want to start doing? 795 minus a 360. Boo. Minus 360 again. You guys are so smart. We got 75. Boom. You guys, that cosine formula, I'm going to go find it. All right, let's leave that 1 on top. Boom, boom. Oh, wait. What do we want to think about that we can add or subtract to get 75? We got to figure out what our alphas and our betas are. Ooh, he says 30 plus 45 is 75.
You just decide if you want to add or subtract.
Totally. Because Mr. Beck James might say, wait, we're trying to get 75. So he might say, I might do
135 minus 60.
135 minus 60? Yeah, that's 75. That'd be an alpha minus a beta versus what I can't remember who said alpha plus a beta with 45 plus 30. I couldn't care less. Does that help, Beck?
Yeah.
Yep, the choice is yours. What do we feel like doing as a class? You're like, dude, those numbers seem small. I'm adding. I like it. So we're going to do 45 plus 30. 45 plus 30. Get out of here, unit circle. Thank you. So I'm going to say this is the same as 1 over the cosine of 45 plus 30. Beautiful. Let's do it. You guys, that's my alpha plus a beta. My alpha plus a beta. I'm going to do 1 over cosine of 45 times the cosine of 30. You guys, we chose 45 plus 30, so that's on the top. So I'd need to stay on the top, and it would turn into minus sine of alpha 45 times the sine of beta 30. Then we're going to go to that unit circle, y'all. We're going to go to that unit circle. And don't forget, we still have 1 over. We need the cosine at 45. Thanks, Nat. Root 2 over 2. Times the cosine at 30. Beautiful. Minus the sine at 45. Times the sine at 30. Perfect. Appreciate you. Killing that. Here we go. Let's keep simplifying. And in order to do that, I still have 1 over. Multiply straight across with your roots, y'all. We'd have root 6 over 4. Yep, when we multiply. Minus root over. Beautiful. Do we already have condoms?
Yeah.
Yep. So we've got 1 over root 6 minus root 2 over 4. You guys did so well on this on your quiz. 1 divided by this fraction is the same as 1 times the reciprocal. Very good. 4 over root 6 minus root 2. Can we leave our answer here? Oh, darn it. We got roots in the bottom. Are you cool? I literally just got rid of my 1. 1 divided by that fraction is the same as 1 times the reciprocal. 1 times anything is just that reciprocal. So I just said bye to the 1. You guys, we got a multiply by the conjugate, which is what in this case?
Root 6 plus root 2.
Very good. Root 6 plus root 2. On top would turn into just 4 root 6 plus
4 root 2.
4 root 2. Okay, on the bottom, this one gets a little uglier. We got this though, people. We got this. Root 6 times root 6. 6. Root 36 is 6. Root 6 times root 2. They're both in the root. Oh, they're going to cancel. Don't be wasting my ink, right? Blake Fisher. So we'd have, what would this be though? Root 12 minus root 12. They're gone. Conjugate, we love it. Minus root 4, which is just 2. So good. On top, I cannot combine these because it's like we have, right, Beck James? It's like we have a 4x and a 4y. We cannot combine those. So we still have a 4 root 6 plus a 4 root 2 over 4. And then you're saying we can cancel something. Boom, chicka pop, chicka. Oh, final answer.
Root 6 plus root 2.
Perfect. Now, people might be doubting me. Be like, dude, or you're going to doubt yourself on the quiz. I don't blame you. I'm going to change my calculator into degrees. And so I'm going to say, oh my gosh, degrees, enter. I'm curious what the secant, how would I type in secant into my calculator? They don't have a button. 1 over the cosine of 795. That's what we started with. Is that the same as root 6 plus a root 2? Boom.
Yep.
I'm with you. Here we go. The sine. Here we go. We got alpha plus beta. Here we go. Write this out for me, guys. What do we think? Sine of 90. Cosine of A. Plus or minus if I started with plus? Plus. Cosine of?
90.
Sine of? Great. Guys, I'm not going to put the unit circle in front of you. 90 degrees is here. Sine. What's the y value there? 1. So we got 1 times the cosine of A, or you could just say cosine of A. Cosine of 90 is 0. The x-coordinate 0 is 0. So what is this all going to simplify to be? Did we want just cosine of A?
Yeah.
Oh my gosh, you're welcome.